back to my channel, and here we are going to be working on the front elevation of this building. As we are asked to draw the front elevation, we have worked on the plan. As you can see it here, now I want to work on the front elevation. And do not forget that we are making use of a scale of 1:100. That means we have to divide each dimension by 100. Okay, now so let's go and work on the front elevation. So what we have to do first is to draw a horizontal line. So we draw a horizontal line, so like this. Okay, so this horizontal line we represent the ground level line. So we have to write GL here. So that's the first thing that we need to do after drawing the horizontal line. So we write GL here, so representing ground level. Now the next thing that we are going to do is that as you are looking at the building in this direction, this is the front of the building. So we are going to see this corner of the wall of the building. Then we are going to see there's here also. So we have a column at this point. Can I call it a column, or we just have what? We just have okay, so we have what? We have an edge here also. So you see this edge. Then we have a column here. Then we also have a column at this. We have an edge here. So we see the edge of this wall. Okay, so we see the edge of this wall, the edge of this wall. So we have a column here. Then we also have an edge of a wall here. So here we are going to see this window. We see this window, these doors. Then we also see this window. So then other thing that we are going to see is the roof, and the type of roof that we are going to be working on here, as said in the specification. Let me bring it. So here we have that the pitch angle is 30 degrees, hipped roof with corrugated aluminum sheets. Okay, so that is the kind of roof that we are going to be working on. So hipped roof is the kind of roof that they made on this building. So let's go and do the first thing that we are going to do. So we are starting from here. So the edge of this wall that we see here. So we have to draw a vertical line down. Okay, so draw a vertical line down, and then at this point, so here also, so we draw a vertical line down because we can see the edge of a wall here also. Then here we have this column here. So we draw a vertical line down here, and then we also draw a vertical line down for the thickness of the column. So we have this. So the next thing that we have, we can see the edge of this wall. So we draw a vertical line down here, and then so we see the edge of this wall here. So we have to draw a vertical line down. So we have what? We have this. Okay. Now, so the next thing that we are going to do is that let's get the floor level. So the floor level, the distance of the floor from the ground level is not mentioned. So we are going to assume a dimension for that. And then, so the dimension will be, just take 1.5 millimeter. So take 1.5 millimeters. And then, so coming to this point, so we draw horizontal line for the floor level. So draw horizontal line from here to this end. So this is the floor level. This represents the floor level. Okay. Alright, so this line represents the floor level. So we can even indicate it. So just extend this, let it come out like this, and then write FL here. So FL for floor level, or for floor line. So this is FL. Alright, so as you can see there on the screen, so the next thing that we are going to do here is to take the distance of the floor to the ceiling, the distance of the floor to the ceiling. But in the specifications, so that is not given. So what we are going to use, most times they make the floor to ceiling height to be 3000 or 3100, either of the two. But I'm going to choose that of 3100. So if I divide 3100 by 100, that will give me 31. So from the floor level here take a measurement of 31 millimeters. So 31 millimeters up. So this is 31 millimeters. So draw horizontal line. So from this point, draw a horizontal line. So we draw horizontal line. So here from this side, so draw to this side. Okay. So that is for the floor to ceiling height. So as we have it there. So the next thing that we are going to do, I want to work on the roof now. So after we have draw these two lines, the ground level line, the floor level line, and also we have taken a distance of the floor of the ceiling from the floor. So we are going to work on the roof here now. Okay, so what we are going to do first is that this line that we have here is the eaves projection. Okay, so this external line that we drew with short dashes line, so it's for the eaves projection. So we have to project this line down. So project this line, so we project it down so that so we can also have the eaves projection on the front elevation. As I said, eaves projection is the distance of the end of the ceiling from the wall. The end of the ceiling from the wall. If you look at the roof of the house where you live, you see that the ceiling extends beyond the wall. It extends beyond the wall, so we take note of that. So that is why we are drawing this line for the eaves projection. As I said, projection is distance of the end of the ceiling from the external wall. Okay, so now that we have gotten the eaves projection, so next thing that we are going to do, since the type of roof that we have here is hip roof, so we need to take the distance of the fascia board. So fascia board from this line, so we take a distance of the fascia board up. So let's make it 5 millimeters for the fascia board. So that 5 millimeters that we have taken, so we are going to draw horizontal line to the other side. So we draw horizontal line like this to the other side. So this is it. So we draw this horizontal line. Okay, so then the next thing that we are going to do is that since the pitch angle is 30 degrees. So what we have to do now is to come to this point with our 30 degrees set square. So with 30 degrees set square, so we come to this point, okay, and we draw a line. So from here at angle 30 degree, okay, then we also come to this point here. So to this point, so come to this point, and we also draw a line at an angle 30 degree. So it goes like this. Okay, so we have this. Okay, so alright, so we have this point. So we have this point. Alright, so the next thing that we are going to do, so this will be the shape of the roof at the front. So hip roof is such a roof in which the four sides of the roof are slanting. So the four sides are slanting, unlike that of the gable roof in which only two sides are slanting. So in the case of hip roof, the four sides are slanting. So this is how it will look in the front elevation. Alright, so the next thing that we are going to do here, we have to show that there is a ridge cap that cover this part. So these two parts, and also the roof extends beyond the ceiling a bit. Okay, so we are going to work on that. So for us to work on that, there is something that we need to do here. So we are going to make use of 60 degree side of the set square, so to draw a line at a right angle to this line. So with the 60 degree set square, so draw a short line here, and then so we come up here. So we also draw a short line from this point up. Then we turn it to this side. So we turn to this side, coming to this point. So we draw a line at a right angle. Okay, it's just a short line. So we also come to this point, we do the same thing. So we draw a short line like this. Okay, so let's say the thickness of the ridge cap on this roof is just, so let's take it as something like 1.5 millimeters. 1.5 millimeters. So we just draw from here. So with the same 30-degree set square. So we draw from here. Okay, so we draw from here and it touches this one. So let's take it down a bit. Okay, so then we also do the same thing here. So 1.5 millimeters. So from this line, so this is 1.5. So with the set square, so we draw this line. So we draw this line. So from here. Okay, so we have it like this. Okay, so looking at what we have here, so we need to extend this a bit, extend this a little bit, so because the roofing material goes beyond the ceiling a bit, and also we do the same thing on this side, just a little. So let's now take the measurement. So let's say the extension of the roofing material is just 2 millimeters from the ceiling. So we also have the same thing here, so 2 millimeters away from the ceiling. So this is 2 millimeters. So here, so we can make this thick line at once like this. Okay, so here we also have it like this. Alright, so I'm going to make this line. I will make it a thick line. So make this a thick line. Okay, so this line also, we make it a thick line. So from here to here. Alright, so then, so coming to this side, so we do the same thing by making this line a thick line from here to here. Alright, so then here also we do the same. So making this line a thick line from here to here. Alright, so having done this, the next that we are going to do, so the fascia board, so we make it a thick line. Okay. Then, so we also make this a thick line to this end. Alright, so then coming down here, so we do the same thing, making this line. Alright, so we have this, so the edge of this wall, let's make it a thick line at once, down, and then, so we also do the same thing on this side, so we make this a thick line to this point. Okay, so then, alright, so now, so the next thing that we are going to do here, so we have worked on the roof, let's leave the roof like this. So the next thing that we are going to do is that there is a beam here, so there is a beam, so there's a beam here, so this beam, it will be above so it will be above the door, so it will be above the door. So so the door, so let's take, because we are going to see this door here, so the height of the door is 2100, that's 21 if we divide by 100. So let's first of all get the height of the door, so that's 21 millimeters. So this is 21 millimeters here. So draw horizontal line all through, so draw horizontal line all through. So from here to this end, draw horizontal line. So now you can now place, so let's put the beam, so let's say the beam starts somewhere around here, so just a little bit above. So let's make it from here to here. So I'm going to make it a thick line. It runs from this point here to this point here. So I'll just draw like this. Okay, and it goes like this. Alright, so this is the beam, and then here we have a column. So we make this a thick line. So this is the column, and then make this a thick line. So what we have here is the column. So this is an edge of a wall. So we make this a thick line, and we also make this also a thick line. So we have this. Alright, so the next thing that we are going to do is to draw. We have this window, this window, this window, this door, and this door, this window. So let's work on this door here. So on this door, so that is D1. So what we have to do for the width of the door, all we have to do is to transfer the distance from here down here. Okay, so that's why I said whenever you have to draw the plan and we are asked to draw the front elevation, just follow the way I'm doing it here. So follow my instruction and do it this way. So we have this. So and then so for the door, what we have to do now is to create the frame. So just move away a little bit, like 1 millimeter. So draw a vertical line here and come to this side. So you draw a vertical line like this. Okay. Um, okay. So we have this. Then so we create a line here, 1 millimeter up. So draw horizontal line here like this. Alright, so that stands for the frame. So let me make this a thick line at once. So a thick line. So we have this. Okay. So um so for the whole of this part of the floor, we are going to see the edge here. So we make this line a thick line all through. While this one, this will be inside, there's a room here. So you can't see the inner part of the room. So we have to make this line short dashes line, because we cannot see the floor in the room there. The same thing applies to this one. So we also make this short dashes line because we can't see the inner part of that room. So we can see the floor from outside. So make it short dashes line. Alright, so now, so this door that we have here, it's D1 from the specification. So we have that the is a metal door. So it's a metal door. So what I'm just going to do, so I'm going to leave it like this. So I'm not going to put any design on it. So what better, we just put something like a small circle here. So for the lock, so I'll just put it here like this. Alright, so we have worked on that on this door, and the door has been placed there. So now, so we have a window here, we have a window here. So let's work on these two windows. So let's start with this one. So part of this particular window will be covered. So it will be covered by the beam. So by the column. So let's just come here and make a little part of it that you can see, because the column has covered that part, so as you can see it on the screen. Okay. Alright, so now, so this is W1. So the height of the window is also is 12 millimeters or 1200, as we are giving here. This is W1, 1200 by 1200. So the width is 12, but also the height is also 12. So the height of the door determines the top of the door is also at the same level with the top of the window. So that's why I do this line all through, so that you can easily produce this window, and this window in the front elevation. So that's the purpose of drawing the line after I've taken the measurement of the height of the window. So the top of the window determines the top of the door. The top of the door determines the top of the window. So if you look at the windows and the door in your building, you see that they are the same level. They be at the same level, except if the floor, so the floor may affect the the top of the window or the top of the door. But most times the window and the door, so their tops are the same level. So let's take note of that. So what I'm to do here now is that I'm going to take a measurement of 12 millimeters from here down. 12 millimeters from here down. This is 12 millimeters. So then I'm going to draw a horizontal line all through, so that I can easily work on the remaining windows. So I draw from here to here, and then so I will also take it from here to here. Alright, so we have this now. Okay, so now So let's work on this window. So we come out a bit for the frame of the window, like 1 millimeter, and also so we take it up here like this, and we also take it down. So you don't have to measure that, just come down a bit. So okay, so we have this window in place, so we are not done with it. Alright, so what type of window do we have here? So they say it's aluminum sliding window. So normally they're supposed to be in 2 pieces. You're supposed to put a line in the middle here. Okay, so we also have to put a line in the middle here. The same thing applies to this. So they be in 2 pieces. Okay, they be in 2 pieces. Alright, so that means, so if I follow this line, so we have it to be in 2 pieces from here to here. Okay, so we have it like this. You can just put 2 lines in the middle here. So they are sliding windows, so we have to put an arrowhead. So one is going in this direction, and then we draw another one, so going in this direction. So that is it. We have finished this particular window. So I'm going to pause the video and do the rest. When I'm done, I will come back and you see what I have done. Alright, other windows have been fixed, as you can see here, and you can see the symbols that I put here. That it's an aluminum window, sliding window, and then we have glass. So the symbols for glass are put there. And then so you have to write front elevation down here, then write the scale used, which is 1:100. So we have drawn the front elevation. I'll see it as simple as I've done it here. Thank you. Keep on practicing, and God bless you.